Hello guys, welcome to Apex Math. My name is Pino. In this video, we go through question 5 from the N4 March 2025 question paper. Question 5.1, we evaluate the following integral, and before we can integrate, let's simplify it. So we have the integral of 3 divided by the sec 4x. Remember that 1 divided by the cos x is equals to the sec x. By cross multiplying, we will find that 1 divided by sec x is equals to the cos of x. So we are going to simplify this and write it as 3 multiplied by the cos of 4x minus 7 multiplied by 5 raised to the power 3 pi x plus 9. So that e raised to the power negative 3x in the denominator, we move it from the denominator to the numerator, and the exponent change sign to positive 3x. And we have the pi multiplied by x raised to the power negative 3. So we separate, and now we have negative 3 pi multiplied by 1 divided by x plus pi divided by 6 multiplied by the cosec squared pi x dx. Now we can integrate, and this will be equals to 3 multiplied by the integral of cos 4x, which is equals to the sine of 4x. And if we were differentiating, we were gonna multiply by the derivative of the 4x, which is 4, but we are integrating, we are going to divide by the derivative of the 4x, which is 4, minus 7 multiplied by the integral of 5 raised to the power 3 pi x. The integral of an exponential function is not available in the formula sheet, so you have to memorize it, and it will be equals to, so in the denominator, we have the ln of the base. We have the ln of the base 5. In the numerator, we have the exponential function as it is, 5 raised to the power 3 pi x. And if we were differentiating, we were going to multiply this by the derivative of the 3 pi x, which is 3 pi. But we are integrating, so we are going to divide by the 3 pi, the derivative of the 3 pi x, plus 9 multiplied by the integral of e raised to the power 3x, which is e raised to the power 3x. And if we were differentiating, we are going to multiply by the derivative of the 3x, which is 3. But we are integrating, we divide by the 3, the derivative of the 3x, plus pi multiplied by the integral of x to the power negative 3, which is x to the power negative 3 plus 1, divided by negative 3 plus 1 minus 3 pi multiplied by the integral of 1 over x, which is available in the formula sheet as equals to the ln x. The formula is available in the formula sheet, but it's available in a reverse, since integration is the reverse of differentiation. Now we evaluate the integral of the cos x squared x, which is equals to the cot x. So integration is the reverse of differentiation. So if that is the derivative of the cot x, the integral of the cos x squared x will be that cot x. So we have pi divided by 6 multiplied by the integral of the cos x squared x, which is that cot x. So the reverse, and The integral of the cos x will also be that sin x. The reverse is actually our integration, so the integral of cos x squared pi x will be negative cot pi x. If we were differentiating, we were gonna multiply by the derivative of the pi x, which is pi. We are integrating, so we divide by the derivative of the pi x, which is pi, plus our constant c. Now we can simplify, so we have 3 sine 4x divided by 4 minus 7 multiplied by 5 raised to the power 3 pi x divided by, so let's start by writing that 3 pi. So we have 3 pi multiplied by the ln of 5 plus 9 divided by 3, which is 3 multiplied by e raised to the power 3x. And the negative 3 plus 1 will be negative 2, so we can have that negative here. And now we have the pi multiplied by x raised to the power negative 2 minus 3 pi multiplied by the ln of x. The pi divided by pi will be equals to 1, and we have that negative multiplied by that positive, which will be equals to negative. So we have negative cot of pi x divided by 6 plus our constant c. If you like, you can move that x raised to the power negative 2 from the numerator to the denominator, and the exponent will change sign to positive 2. And this will be our answer for the first question. Question 5.2, we evaluated the impedance of a circuit given by the equation. So the impedance is just resistance in an AC circuit, and is normally represented by the letter Z, not V. So we just solve this integral. You don't have to know what impedance is for you to evaluate this integral. So we have the integral of the sine x. The integral of sine x is negative cos x, available in the formula sheet in the reverse. The integral minus the integral of cos x, which is sine x. So we have minus and then the integral of cos x. And we have pi divided by 2 as our limit. Pi divided by 2 and 0. Now we substitute. We start by substituting the pi divided by 2. So we have that pi over 2. So we have negative cos of pi divided by 2 in the place of the x minus the sine of pi divided by 2 and a big minus in between the two. So we have, now we substitute that 0. So in the place of the x, we substitute 0. So we have negative the cos of 0 minus the sine of 0. And this will be equal. So if you are working with degrees and not radians, in the place of the pi, substitute 180 degrees. So you'll have negative 180 degrees in the place of the pi divided by 2 minus the sine of 180 degrees in the place of the pi divided by 2. So if your calculator is in radians, you can work with the pi. But if it's like most calculator, which is in degrees, you will work with the 180 degrees. If you know how to convert your calculator to radians, you will work with the pi. Or if you want to work with degrees, you'll substitute 180 in the place of the pi. So it's either you work with radians if your calculator has R at the top, or you work with degrees if your calculator has D at the top. This will be equals to negative cos of 180 divided by 2 is equals to 0. Negative sin 180 degrees divided by 2 is equals to negative 1, minus the negative cos 0 is equals to negative 1, and the sine of 0 is equals to 0, and this will be equals to negative minus minus 1 is equals to 0. So we have this as 0 ohm, and this will be our impedance. Question 5.3.1, we sketch and clearly indicate the area enclosed by the two graphs y is equals to x squared minus 2x minus 3 and the x-axis. We show also the representative strip used to calculate the area in question. We sketch our parabola and the x-intercept occurs when the y is 0. So we have 0 is equals to, we factorize the factors of the x squared is x, and the factors of 3 will be 3 and 1 with negative and positive, and our x minus 3 will be equals to 0, or x plus 1 will be equals to 0. So our x is equals to 3, or our x is equal negative 1. So let me make some room for the graph. Since that x squared is positive, our parabola will be a smiling one, and our x-intercept, we have negative 1 and 3. We can determine the turning point even though it's not necessary. The turning point will be the two x-intercepts, we add them and we divide by 2 to get the x-intercept of the turning point. Or you can use the other formula. So this will be equal to 2 divided by 2, which is equals to 1. And for the y part, we substitute the 1 where there is x. So we have 1 squared minus 2 multiplied by 1 minus 3, which will be equals to negative 4. So we have the turning point as 1 and negative 4. So let's label it as 1 and negative 4. And the y-intercept is negative 3. There was a plural for graphs since we have two graphs, the parabola and the x-axis. We shade our area between the two, the parabola and the x-axis. Remember that the x-axis is a function y is equals to 0. It's also a graph. Now we draw the representative strip used to calculate the area. The representative strip always has to touch the two graphs. When it's horizontal like that, it's only touching one graph, but when it's vertical, it's touching two graphs, the parabola and the x-axis. So it has to be vertical. When it's horizontal, it's only touching the parabola, not the two graphs. We label it as dx, or you can label it delta x. We use integration to determine the value of the enclosed area. We calculate the area between the two graphs, the area between the y-axis and the parabola. And from the formula sheet, we have that formula, the one which has y2 and y1. So let's copy this formula. So our area is equal the integral from x1 to x2 of y2 minus y1. Sometimes they say y1 minus y2, but I will show you guys the trick. And we have the dx. Our area will be equal the integral from x1 to x2. So our x1 will be the smallest number between our area, the -1, and the x2 will be that +3, the values between our area. We had two functions. The y is equal to x squared minus 2x minus 3, and the x-axis. Like I said, the x-axis is a function y is equal to 0. So on our area, we start by writing the function which is at the top of the area. So in this case, y is equal to 0. So we place y is equal to 0 at the beginning of the integral minus y1. So the second one will be the function which is below the area, the parabola. So we minus this with the parabola x squared minus 2x minus 3 dx. If you started with the parabola, you will get negative area. So if you get negative area, just multiply it by -1 or take its absolute value. So our area will be equal the integral from -1 to 3. So we distribute that negative, and we get negative x squared plus 2x plus 3 dx. So now we can integrate. Our area will be equal the integral of negative x squared, which is negative x squared, plus 1 in the exponent. We also divide by the 2 plus 1, plus 2 multiplied by the integral of x, which is x raised to the power 2 divided by 2, plus the integral of the 3, which is 3x. We have our bounds from 3 to -1, or from -1 to 3. Let's simplify. Our area will be equal negative x raised to the power 2 plus 1, which is 3, divided by 2 plus 1, which is 3, plus 2 divided by 2 is equal to 1. So they will cancel out, and we'll be left with the x squared plus 3x with our boundaries, the 3 and the -1. We start by substituting the bigger number where there is x. So our area will be equal, we will substitute that 3 where there is x. So we have negative into 3 raised to the power 3 divided by 3 plus 3 raised to the power 2 plus 3 multiplied by 3, and a big minus in between the two. Now we substitute that -1 where there is x. So we have our parentheses, and we have negative into -1 raised to the power 3 divided by 3 plus -1 squared plus 3 multiplied by -1 close parenthesis. Area will be equal, so I suggest that we calculate first this part, then later we calculate that part. So for the part which we substituted 3, we get 9, and the part which we substituted -1, we get -5 divided by 3. And our area will be equals to 9 minus 5 over 3, which is equals to 32 divided by 3. In decimal form, this will be equals to 10,667. Our area is calculated in square, but we were not given any SI unit, so we use unit square. Question 5.4, we simplify by integrating the following. We have this as, so we can take in the numerator, let's take that 3 as our common factor. And by taking the 3 as a common factor, the parenthesis will open up to x cubed minus 27. And in the denominator, we take 2 as our common factor. So we take 2 as our common factor, and our parentheses open up to x minus 3 dx. The 3 divided by 2, we can write them out of the integral since they won't affect the integration process. So we have 3 divided by 2 multiplied by the integral of x cubed, and the 27 we can write it as 3 raised to the power 3. If you are able to factorize a cubic expression, I will encourage you to factorize the x cubed minus 3 raised to the power 3. But if you cannot factorize like me, let's use the long division method. So we write the 3 raised to the power 3 as 27. In the denominator, we have the x minus 3. We use the long division method to simplify the integrand, the x cubed minus 27 divided by x minus 3. So we have the x minus 3 right here, and the x cubed minus 27, but we rearrange it in standard form. So we have x cubed plus 0x squared plus 0x minus the 27. Now we start with the long division method. So we divide the x cubed with the x, and this will be equal x squared. We take the very same x squared, we multiply it with the x minus 3. So x squared multiplied by x will be equal to x cubed. X squared multiplied by negative 3 is equal to negative 3x squared. Now we minus, so x cubed minus x cubed will be 0. 0x squared minus 3x squared will be positive 3x squared. We drop down the 0x next to the 3x squared. We take the 3x squared, we divide it with the x, and the answer will be equal to positive 3x. Taking the very same 3x, we multiply it with the x minus 3. 3x multiplied by x will be equal 3x squared. 3x multiplied by negative 3 will be negative 9x. Now we minus. 3x squared minus 3x squared is 0. 0x minus 9x will be equal positive 9x. We drop down at a negative 27 next to the 9x. We divide, so 9x divided by x is equal to positive 9. We take the very same 9, we multiply it with x minus 3. 9 multiplied by x is equals to 9x. 9 multiplied by negative 3 is equal to negative 27. We minus 9x minus 9x is 0. Minus 27 minus minus 27 is 0. We have nothing to drop down. Finally, we can integrate. So we have that x squared plus 3x plus 9 as the simplified version of the x cubed minus 27 divided by x minus 3. We have that 3 divided by 2, which we keep. Inside the integral, we simplified, and now we have the x squared plus 3x plus 9 dx. If you know how to factorize a cubic function, you will still get the x squared plus 3x plus 9 without all these steps. So now we can integrate. We have 3 divided by 2. The integral of the x squared will be equals to x raised to the power 2 plus 1 divided by 2 plus 1 plus 3 multiplied by the integral of x, which is x squared divided by 2. The integral of the 9 is equal to 9x plus c, and this will be equal the 3 divided by 2 multiplied by x raised to the power 2 plus 1. 2 plus 1 is equal to 3. Even in the denominator, 2 plus 1 is equal to 3 plus 3x squared divided by 2 plus 9x plus c. If you like, you can distribute the 3 divided by 2, but I'm just gonna leave my answer here. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.